Today, we are going to define what the cloud is and how it can be used, define what SaaS is, software as a service, describe the usage of a web mapping tool, explain what a story map is, and describe the goals of at least 4 professional or research organizations involved in the geospatial field. I don't know that I actually even included that last one in the slides, but you should know that from your book. You definitely learned about that book. So, GIS 10 years ago. Well, GIS now compared to 10 years ago. Remember that video that we saw with the Canadian GIS where they had those long rows of drawers with paper maps? And they talked about how it was really difficult to get new data. Well, that's not a problem anymore. Now we have GPS systems that are the main source of new GIS data. We also have all those satellites for remote sensing that are the source of a lot of data. Sorry, I have a cold, so if I like zone out or start rambling, somebody stop me. Digital map images like satellite photos and scanned maps are often used as base maps. We also use remote sensing like thermal imagery for GIS data now. The Massachusetts GIS actually goes through and looks at satellite imagery to find out where new construction is for the ambulance services so that they can add them as a new address, because towns are supposed to notify them, but don't always. So this is a really bad chart, and I apologize. In the past, on the left-hand side, the GIS was mostly data conversion, a little bit of attribute tagging, and very few spatial analysis. Now, it's not much data conversion. Still a little bit of attribute tagging, which is mostly automated now, and a lot of spatial analysis. We are constantly comparing one thing to another. I just helped someone in Intro GIS compare a college education to the Democratic vote. So we do lots of spatial analysis now. In the past, just having an aerial photograph was worth 1,000 words. Now we're doing virtual reality. In the past, maps and diagrams were of how it is or how it was. Now we have real-time displays that are usually interactive and continually updated of how it is and how it might be in the future. In the past, web portals served static data sets. They were just one point in time. Now, web portals can serve continuous sensor-derived data. So the water flow sensors, say, on the Connecticut River, or even the Greenfield River, where I go tubing, there's a sensor in the dam, so it tells us the flow rate before we go out there, so I know if it's going to be good tubing or not. Similarly, temperature, CO2, there's continuous sensor-derived data. So we know if it's going to be a high smog day. So it's not about systems anymore. GIS is not about systems anymore. It's about the science of understanding place and time, which is geography. And hopefully I've ingrained in all of you that geography is the discipline that is very interdisciplinary. That this GIS can be used in so many different fields. I talk a lot about ecological things, but there's been videos of how construction uses it, and other fields. So in the past, everything was 2D. There wasn't even the option for 3D. Now we have effective 3D visualization. We can make short clips to incorporate time. We can now also incorporate touch, sound, and smell into VR, essentially. And now users are participants, so we interact with the models. The public can plan things. The public can add data point. All right, so that was enough about past versus present. Blow my nose before we go on to the next one. It's going to be recorded for all time. Okay. Let's go into GIS in the cloud. This is where we're going. And actually kind of where we are right now. Some people, municipalities, and organizations are slow adopters of this. But it's becoming more and more and more popular. And pretty soon, everybody is going to be collaborating in the cloud, making their maps in the cloud. So what is the cloud? The cloud is basically online hosting. It's not actually in any clouds. It's actually nowadays sometimes underwater. There's some cloud hosting underwater, which is pretty cool. Otherwise, it's a bank of computer servers somewhere in a warehouse. And that's what your cloud is. It's just online storage or online, not just storage now, it's interactive. So it's still storage, but interactive storage. Yeah, Haley, it's where all the information is kept. Yep. So I'm sure you guys are familiar with Google Classroom. Not Google Classroom, I'm sorry. Google Docs, Google Drive, which is actually where I save my lecture slides so I can access them. You may not be familiar with Dropbox, but that lets you store data and files somewhere else and access it via the web browser. There's also Microsoft OneDrive. There's a whole bunch of virtual cloud services. So streaming of when you stream TV shows from Netflix or Hulu, those are all stored in the cloud. So rather than stockpiling movies on DVD or Blu-ray discs or VHS, if any of you are old enough to remember that, the films are kept in the cloud and delivered to you when you want to see them on the internet. So take that idea of a movie in the cloud and think of it with geospatial technology where you have maps. You don't just have maps. You also have the tools and the software stored in the cloud and access on demand via the internet. So this week in lab, we'll play with ArcGIS Online. The cloud is becoming more and more important to geospatial tech. For instance, being able to have huge amounts of data accessible via streaming is an invaluable tool. Now, when I do a lot of spatial analyses, I'll go straight to the cloud, which is actually the Living Atlas that we talked about, and pull data from there to make seamless topographic maps or high-resolution satellite photos. Hold on. All of that can be streamed from the cloud at the click of a mouse. So this removes the need to have those rows and rows and rows and cabinets filled with different topo clods, and having to rely on bringing the right ones into the field with you if you're doing field research. Makes it all accessible on something like your phone. Does anybody have questions, or what are your questions about Cloud GIS? So, software as a service is a key part of working in the cloud. With SaaS, you only need a web browser to work with cloud services. You don't need to download and install any software onto your computer or even an app onto your mobile device. All of the data storage, the tools, and the products are held on the server that you connect to with the browser. Gmail is a good example of software as a service. You connect to it via a web browser, and you don't need to download an email program to your computer to do so. Long time ago, back before Gmail, people would host their own email servers, and they would need software on their computer, like Microsoft Outlook, to access the email on the servers. Now Gmail just takes care of all of it. You can still connect, but it's a great example of software as a service. Similarly for GIS, ArcGIS Online is SaaS for geospatial technology. All of the layers and all of the tools are stored on Esri servers, and all you need to access them and work with them are in the web browser. You can play with that, accessing things through the Living Atlas. That's it. Oh boy. And this image right here is actually a software as a service that monitors air quality. I'm going to talk about the basic uses of a web mapping tool. So at their heart, GIS maps are simple. You start with a base map, mash it up with your own data layers, and then you add tools that support what you want your users to do with the map, whether you want to tell a story, perform analytical studies, collect data in the field, or monitor and manage operations. So you get your base map. Actually, they provide the base map, but you choose your base map, put data layers on it, and then publish it, add tools that, so that your users can do stuff with it. And that's a web mapping tool, easy peasy. Now, story maps are a great usage case of web mapping tools. The story map uses a pre-designed template to incorporate maps, images, links, tools, and so on into a single standalone web application. Some templates are available right through ArcGIS Online, but you can also modify them to fit your own needs. And there are several good ones. There are some really good ones. Ooh. Do you all celebrate Thanksgiving? Let's do mapping the Thanksgiving harvest. Even if you don't celebrate Thanksgiving, knowing where some of your food is grown is a pretty cool thing. So story maps, you really just scroll through them. There are some parts that are interactive. There's text, and then maps, which is like what this whole class is about. So that's the important part. So this map in particular has the production of turkeys, and you can see the bigger dots are more turkeys. So in North Carolina, I don't know what's behind there. It looks like 15 million turkeys were sold versus, Massachusetts, It's a bunch of little farms. I wish I could zoom in. Ah, there's zoom in. So I do know that Purdue is located down here because I've driven past, and that could be one of the things. It does say that Minnesota raises more turkeys than any other state. So it looks like there's a whole bunch of farms there. Three farms raising turkeys. 7 million in that county. Yeah, a whole bunch. So, cool. Conversely, Massachusetts is huge in cranberries. Oops, no, go back one. So if you click on it, it's interactive. You can see that 10,740 acres of cranberries were farmed. I think if I make this a little bigger, it'll be better. In a moment. Make it just a little bit bigger. There we go. That's much better. All right. Lots of cranberries in Massachusetts. No, go back to cranberries. Also in Wisconsin. I had no idea. And some on the West Coast too. Oh, because they're cold weather wetland plants. And there's actually lots of wetlands in Wisconsin. Some people eat sweet potatoes for Thanksgiving. Some people eat sweet potatoes all year round. A lot of them are in California. Almost 16,000 acres. Plus another 30. So when I click on that, it's actually, so I clicked like here. So it's giving me the 2 closest. Oh, now it's giving me the 6 closest. The interactivity is not an exact science. But also there's a lot of sweet potatoes, wherever this one is, Calhoun County, Mississippi, and other counties nearby. Lots of sweet potatoes there. Lots of sweet potatoes. Virginia. Really? Wow. Okay. Regular potatoes, of course. Most of them come from Idaho. 77,000 acres in Idaho, but also a lot of small farms all around the U.S. that grow potatoes. It says Idaho and Washington provide more than half of the total U.S. potato crop. That's pretty cool. Potatoes are stupid easy to grow. If you ever have a potato at home that's growing eyes out of it, you can plant it and you will get new potatoes that grow underground. It's really cool. You have to plant them in the spring, obviously. If people planted it now, it would just turn to mush. So green beans. Florida and Wisconsin are leading producers for green beans. But once again, lots of small farms all over growing them. Like 7 acres on 27 farms in Washington County, Maine. Brussels sprouts are not widely grown, mostly because they are newly popular. So a lot of it's in California. Over 2,000 acres in that part of California. Another, my clicker's not working. There we go. Another something acreage. I can't see because it's behind it. So most of the Brussels sprouts are grown in California. Pumpkins! Holy moly, most pumpkin pie filling that they can are grown in Illinois. But once again, if you've ever driven past a farm in Massachusetts, everybody's growing pumpkins. Most of them, they're growing for jack-o'-lanterns. So that's why they talk about canned pumpkin pie filling. Wow. I don't know if you've noticed, but not a whole lot is grown in this area. Can anybody tell me why not a lot's grown in that area?
Climate?
Climate, yeah. Chris, what do you know about the climate in this area? Haley says it's the dusty area. Yes, it's dry, and there is it's dry. There's not a lot of rain. There's not a lot that grows there, and also part of this is the Rockies, and you're not going to grow anything on the eastern slope of a mountain. Not much, at least, not crops, not major crops. Good. So pecans, I didn't get pecan pie this year, but pecans, a lot of them are grown in New Mexico. But also it's obviously a heat-loving tree because it's mostly in the southern states. So cool. So that's a great story map that tells you where different crops are grown. Now, all right, cool. So let's talk about the future of GIS. It's already there. I mean, it's ubiquitous for everyone, everywhere. We are using geospatial technology every day without even realizing it. Like I've said before, anybody who uses Waze or Google Maps or whatever you use for a GPS, that's GIS. Anybody who still plays Pokemon Go, that's GIS. Yeah, so it's ubiquitous. And as computers and servers get higher performing, have more RAM essentially, we're going to be able to do advanced spatial analysis, advanced modeling, advanced simulation. Right now, there's a little bit of a problem with big data sets and viewing big data sets. So as computers get better, it'll be easier to do that. The future of GIS is also lots of do-it-yourself and volunteer GIS. OpenStreetMap is a great example of that. Flickr also has a API for mapping your photos. But it's data created by citizens, where you can go in and add to the map. Or my street's a one-way. It was going the wrong way in Google Maps. So I went in, created a ticket in the help screen and said, hey, you have the wrong way, going the wrong way. Technically, that's volunteer GIS, even though I'm a professional. Now I have a really fun video. I have to make sure that I share computer sound. Optimize screen sharing for video clip. Okay, let's play it. So this is gonna tell you about what's next. So the pace of change is rapidly accelerating. It threatens our natural world and our future as humans. So what is next? Well, it's in your hands. GIS software is active and continues to build new developments. As a geospatial analyst, specialist, or practitioner, you have the ability to use or misuse the power of GIS to study and solve some of the world's major problems. What problem do you want to solve?